Okay, so we are back. We're going to be talking about our exponential functions. This is day 3 of our notes. We also have we're going to be breaking it down into kind of 2 different rules here. So we're going to be talking about the recursive rule first, and then we'll talk about the explicit rule. But to start off with, let's go with the recursive rule. So we can see that we have our f of 3 is 5 and then f of 4 is 10. So each time it's doubling. So we have 2, so we have 5. 5 times 2 is 10. 10 times 2 is 20. And then 20 times 2 is 40. Okay, so our recursive rule really simply states this. Whatever we are asking about now, it equals the previous term and in this case, we're multiplying by 2 each time. Okay, so we're saying times 2. And the way that we would write that in function form, it would be f of n equals f of n minus 1 times 2. Okay, so that's our function recursive rule. This is when I ask on the test, I say what is the recursive rule? This is what you're looking for. F of n equals f of n minus 1 times whatever the common ratio is. Okay, so this is your common ratio. Common ratio. Okay, so that's your common ratio. Okay, so next one, we're seeing we are getting 20, and then it goes 10, and then we're going to go 5. So each time we're dividing by 2. So, and then this one would be 5 halves. So our recursive rule. So again, it's the now. So we're just going to write it in function notation. So f of n equals f of n minus 1. Okay, so everything is the same so far. Now the last thing, we're just multiplying it by 1/2. Okay? So this is our common ratio. So the only thing that's changed here is the 2 and the 1/2. So our next one, oh, this one's tricky. Okay, so we have 20.58, 9.24, okay? And so then you're going to take your calculators and you're going to go 2.94 divided by 20.58, and that will give you your common ratio. Okay, so I'm going to grab my calculator. It's not something I'm going to be able to do in my head. Not that lucky. Okay, divided by 20.58. And so our common ratio is 0.142, blah, 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 blah. All right, so it looks like we can say times 2.94. Is that right? Yep, so we got 0.42. And then we can say times one more time. So I'm going to set up my calculator, 2.94 divided by 20.58. And we're going to say times 0.42. So we get 0.06. Okay, so our ratio here, so let's go again, 2.94 divided by 20.58. So our common ratio is 0.142. Well, let's round it to the thousand. So our common ratio, 0.143. Okay, that's our common ratio, which is R. And so we're going to say f of n equals f of n minus 1 times 0.143. And there's our recursive rule. So the only thing that's changed in each one is you've got to find the common ratio. Okay, so these are finding the common ratio. It would be just the second one divided by the first one, and that's 1/2. The second one divided by the first one, and that's 2. And so that's where we're getting this 2. That's where we're getting this 1/2. That's where we're getting this 0.413. Okay. All right. Our next section. So that was the recursive rule. Now we're going to just practice a couple of the substituting numbers into our exponents. So f of 5. So we would say f of 5 equals 2 to the 5th power. Okay, so 2 to the 5th power. Remember, on your calculator, you're going to use that little exponent button, and we got equals 32. And then f of 0, and this one you shouldn't need a calculator for because anything to the 0 power is 1. Okay, so our next one, we would do f of 4. So I'm looking at f of 4 equals 5 to the 4th, and you would put that on your calculator. Same thing with these, and I want you to answer this question. This is a part of your homework, is number 8. What's going to end up being different between 15 and 16? They both have -2, but you've got to tell me what the difference is and why they are different, okay? So say 15, it says 6 and 7 here, but in yours it should say 15 and 16. Or sorry, 16, yeah, 15, 16. In yours, it should say 15, 16, okay? Okay, so next page. All right, and so now we're going to start getting into the explicit rule. Okay, let me turn mine over just to make sure I'm not telling you anything crazy. Okay, so first of all, first thing you should always be doing is looking for the common ratio. Okay, so in this case, we're going to do our first term, our second term divided by our first term, which is 2. So our common ratio is 2. So if I said write the recursive rule for this, you would say f of n equals f of n minus 1 times 2. And that's it for the recursive rule. The explicit rule is a little different. So now we're going to try to figure out, how do you write this explicit rule? How do you come up with your answer here? So let's put some marks on here. Okay, we're going to number it. So 1, 2, 3, 4, 5, 6. And then our 2, 4, 8, 16 is going 2, 4, 8, 16. So it's way up there. So you can see how it's growing each time, right? So we're going to go 2, 4, 8, 16. So you can see that this is not a straight line anymore. That's actually going to end up being a curve. Okay, so how do you figure out, like, what, when we say an explicit rule? Okay, so I'm going to tell you what the rule for this one is. It is f of n equals 2 to the n. Okay, so how do you figure out that explicit rule? How is it that this is working? Well, the best way that I can say is that if you write out your answers in function or in factored form, so 2 in factored form, nice thing about 2 in factored form is it's just 2. Well, 4 in factored form is 2 times 2. 8 in factored form is 2 times 2 times 2. 16 in factored form is 2 times 2 times 2 times 2. So you're seeing this grow here, right? So each succession, so this is 2 to the first power, right? If we just wrote it 2 to the first power. 2 times 2 is 2 to the second power. 2 times 2 times 2 is 2 to the third power. And then this one is 2 to the fourth power. So you can see that the thing changing here is 1, 2, 3, 4. So this becomes our n, right? 2 is always the same. So 2 is going to be here, okay? So our 2 is all the way through. This is 2, 2, 2, 2. The thing that's changing is the n. So 1, 2, 3, 4. Okay, so let's take another look at another example that's a little different so you can see this one. Okay, so let's number it down here again. 1, 2, 3, 4. We're only going to go to 4 here. 1, 2, 3, 4. Okay, and so we have 3, and then we're going to go 6, 9, 12, 15, 18, and then we've got 21, and I'm way off the graph because that's what exponential functions do. They grow exponentially. Okay, so I've extended the graph up here. I'm just writing in, I'm copying those numbers. I'm counting by 3 because these are all multiples of 3. Okay, so first one is 1, 3. Pretty straightforward, 1, 3. Second one is 2, 6. Over 2, up 6. And then over 3, up 12. And then over 4, up 24. Okay, so you can see how it's jumping and making that exponential curve again. Okay, so how do you okay, so now we could say the recursive rule is f of n equals f of n minus 1 times 2. So the recursive rule is still pretty easy. We can see that each time we're multiplying by 2, right? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So that's where our 2 is. But our explicit rule is a little different, though, because we've got to have some type of starting point, right? This one was nice because it started at 1, right, or 2. It started with our whatever our common ratio was. But that's not the case here, right? Our common ratio, this one was 2 and 2, right? So our common ratio was our factor being multiplied. But our common ratio is not where we're starting anymore. This one's starting at 3. It's not starting at 2. So how do you account for that? Well, the nice thing that you can think about, or the nice thing that you can do when you factor this out, is start looking for what's being multiplied more than once when you factor out. So this is 3 times 1. It equals 3. Okay? This says 3 times 2. That's 6, right? This one is 3 times 2 times 2. Okay? So each time we're multiplying by another 2. This really is, okay, so, and then 3 times 2 times 2 times 2. Okay, so 6 times 4 is 24, so 3 times 2 times 2 times 2. Okay, so you can start seeing where our exponent's coming from. So the 3 is only being multiplied by 1 time. Okay? So there's only 1 3 being multiplied in there, but the repeated multiplication happening is that 2. So this is going to be 2 to the n. Okay, but it's not quite right, okay? Because if we put 1 in here right now, well, 1, if we say 1, 2 to the first power is 2. 2 times 3 is 6. Well, 6 is supposed to be the second one. So what we need to do is modify this to be 3 times 2 to the n minus 1, okay? So we would write that in function notation as f of n equals 3 times 2 to the n minus 1. Okay, so what it's really saying is find your original factor, find that common one, okay? That's the very first thing that goes in there. Everything else is based on how many times something is being multiplied, okay? So, like if I gave you, let's do another quick example down here, okay? This one I'm making up on the fly, so we'll see if we can figure it out. All right, so we have n and we've got f of n, okay? And we're going to just say 1, 2, 3, 4. So it's really the same thing that we've done up here, only this time I'm starting at 5. Okay, and then I'm going to go 5. And then we've got 15. And then we've got 45. And then we've got 135, okay? So our job is figure out the explicit rule for it, okay? So you can see here 5 times 1 is 5, okay? The second one, we've got 5 times 3, okay, is 15. And this third one is 5 times 9, but 9 is 3 times 3. Okay, so you can see how it's growing. That 5 is staying the same all the way through, right? And so it's 5 times 3 times 3 times 3. Okay, so our explicit rule here would be f of n equals our starting point of 5 times 3 to the n minus 1. Okay, so hopefully that second example helped you out. I'm going to let you guys do that on number 11 on your own. I've given you one more example than other people are getting in their notes. Let's see what we got. So this is going to be some extra work in class if we need more practice. But I'd like you to, for your homework, do 18, 19, 20, 21. I can use these for some extra practice for the explicit rule and the recursive rule. I might do that in another video. But your homework, your true homework for the day is 14, 15. Okay, so it's going to end up being page 14 and 15. So 14, 15, your job is to get those done. I'm going to do another video where I do some of the problems for number 13. Hopefully I can get those done. But this video is at 15 minutes, so I'm going to head out. Good luck, y'all.